our lesson for today is solving problems involving parallelogram, trapezoid, and kite by Ma'am Marjorie T. Lichtag. So this module is developed by her. The learning objectives, we have recall the properties of parallelogram, trapezoid, and kite, differentiate parallelogram, trapezoid, and kite, solve problems involving parallelograms, trapezoid, and kites. Let's recall the properties of parallelogram. First, trapezoid. It has one pair of opposite sides that are parallel. So we have here side SA or base SA that is parallel to side EF. And we have also another pair of non-parallel sides. These are the legs. So we have side SE and side AF. So they are not parallel. We have also isosceles trapezoid. The base angles of an isosceles trapezoid are congruent. So angle B and angle E are congruent, and angle T and angle S are also congruent. Number 2, opposite angles of an isosceles trapezoid are supplementary. So when we say opposite, we have here angle B and angle S, and then angle T and angle E. So for sure. So or the measure of angle BTS plus the measure of angle BES is equal to 180 degrees. So these are opposite angles. So specifically this angle T and angle E are opposite angles, and the sum of their measures is equal to 180 degrees. So as well as with this angle B and angle S, or in other words angle TBE and angle EST. So these are also another pair of opposite angles that is equal to 180 degrees. The sum of their measures is equal to 180 degrees. Okay, another one, the diagonals of an isosceles trapezoid are congruent. So when we say congruent, the measures are also equal. So the distance from B to S is equal to the distance from E to T. The legs of an isosceles trapezoid also are congruent. So when we say the legs, these are the non-parallel sides. So side BT and side ES. So when we use the line segment symbol, we use also the congruent symbol. So line segment BT is congruent to line segment ES. Or we can just say BT, or the distance from B to T, is equal to the distance from E to S. Okay, another one, we have kite. Distinct pairs of adjacent sides are congruent. So what the distinct sides are KI and IT. Also with KE and ET. Okay, so another pair of distinct adjacent sides. And then number 2, we have diagonals are perpendicular to each other. So line segment IE is perpendicular to line segment KT. And also we have the area is equal to 1/2 the two diagonals, the product of the two diagonals. That's why we have here 1/2 times the quantity IE times KT, the distance from I to E times the distance from K to T. We have also parallelogram. The first property is opposite sides are parallel and congruent. Second, opposite angles are congruent. And number 3, the diagonals bisect each other. Okay, we have also rectangle. A rectangle is a parallelogram. Second, opposite sides are parallel and equal in length. And all angles are right angles. And lastly, diagonals bisect each other and equal in length. We have also the rhombus. A rhombus is a parallelogram. It has opposite sides that are parallel. All sides are equal in length. We have also opposite angles are equal, and the diagonals are perpendicular and bisect opposite angles. And lastly, we have square. A square is also a parallelogram that has all sides that are congruent. All angles are right angles, and diagonals are perpendicular and bisect opposite angles. Okay, so what are quadrilaterals? So, uh, what is the importance of quadrilaterals to our real lives? So, here is it. Here is the answer. Quadrilaterals are everywhere. We see them on signs, buildings, work of art, books, computers, floor designs, and many more. In this module, we will learn how to solve problems involving them using their properties. Okay, so we have the first example. Quadrilateral wish is a parallelogram. If the measure of angle W is equal to x plus 15 and the measure of angle S is equal to 2x plus 5, what is the measure of angle W? So, solution. Since opposite angles are congruent, then angle S and angle W are opposite angles. So, hence, the measure of angle S is equal to the measure of angle W. Then, by substitution, we have angle S is equal to, the measure of angle S is equal to 2x plus 5, and the measure of angle W is equal to x plus 15. So we can equate them with each other. Therefore, 2x plus 5 is equal to x plus 15. So transposing 5 to the right, we will add the additive inverse of positive 5, and that is negative 5. So 2x plus 5 minus 5 and x minus 5 plus 15. So we have now uh, negative 5 plus 15 is equal to 10. And again, to get rid of x on the right side of the equation, we will add its additive inverse to both sides of the equation. And that is 2x plus negative x is equal to x plus negative x plus 10. Okay, so x minus x is now equal to 0. So we have only now the constant on the right side of the equation. And 2x minus x is equal to x on the left side of the equation. Therefore, we can say that the measure of angle W is equal to 25 degrees. So why? Substituting the given originally, which is equal to x plus 15, and we got the value of x is equal to 10. Therefore, 10 plus 15 is equal to 25. And the units for angles is given by degree measures. Therefore, we can say that the measure of angle W is equal to 25 degrees. Okay, so we have the first example. Quadrilateral WISH is a parallelogram. If the distance from WI is equal to 3y plus 3, and the distance from H to S is equal to y plus 13. How long is line segment HS? So we have the solution. The distance from W to I is equal to the distance from H to S. So why? Because they are opposite sides. Because they are parallel and opposite, they have uh, the same measure, or they are congruent. So by substitution, 3y plus 3 is equal to y plus 13, and transposing y to the left side of the equation, we will have 3y minus y, and transposing positive 3 to the right side of the equation, we will have 13 minus 3. So 3y minus y is equal to 2y, and 13 minus 3 is equal to 10. And then dividing both sides by 2 to find the value of y. So we have now 2y divided by y is y, and 10 divided by 5 is 10 divided by 2 is 5. Okay, so the distance from H to S, from the original given, we have y plus 13. Since the value of y now is equal to 5, we will substitute it. So 5 plus 13 is equal to 18. Therefore, the distance from H to S is 18 units, or line segment HS is 18 units long. Example 2, given quadrilateral post is an isosceles trapezoid with line segment OS parallel to line segment PP. Line segment ER is its median. If the measure of angle P is equal to 2x plus 5 degrees, and the measure of angle O is 3x minus 10 degrees, what is the measure of angle O? So note, opposite angles are supplementary. So the measure of angle P plus the measure of angle S is equal to 180 degrees. Since angle S and angle O are one pair of base angles that are congruent, then we can say that the measure of angle P plus the measure of angle O is also equal to 180 degrees. So by substitution, we have 2x plus 5 plus 3x minus 10 is equal to 180 degrees. Combining now, 2x plus 3x equals 5x, and 5 minus 10 is equal to negative 5, and then bring down 180 degrees. So again, for a negative 5 on the left side of the equation, we will bring it to the right side of the equation. So negative becomes positive. So 180 plus 5 is 185. And then to find the value of x, we will divide both sides by 5. So 5x divided by 5 is x, and 185 divided by 5 is 37. And since we are looking for the measure of angle O, by substituting from the original given, which is the measure of angle O is equal to 3x minus 10 degrees. So 3 times 37 minus 10. And 3 times 37 is 111. And then bring down negative 10. 111 minus 10 is 101 degrees. Therefore, the measure of angle O is 101 degrees. Okay, another example here. Example number 3. So, the first part of the given of the problem is given kite ABCD. Find the measure of angle BAE if the measure of angle AEB is equal to 15x and the measure of angle ABE is equal to 8x minus 10. So the solution is this. So the measure of angle AEB is equal to 90 degrees. So why 90? Because it is the intersection of the diagonals. And the diagonals of a kite are perpendicular to each other. So since they are perpendicular, therefore the measure of the angles at the intersection is 90 degrees. And then given the measure of angle AEB, which is equal to 15x, we will just substitute. So 15x is equal to 90. And then to find the value of x, we will divide both sides by 15. So we have x is equal to 6 degrees. The measure of angle ABE is equal to 8x minus 10. Since the value of x is equal to 6 degrees, 8 times x is 48 minus 10. Therefore, the measure of angle ABE is equal to 38 degrees. And since we will find the measure of angle BAE, we note another theorem in a triangle. The sum of the interior angles of a triangle is 180 degrees. Therefore, the measure of angle BAE plus the measure of angle ABE plus the measure of angle ABE is equal to 180 degrees. Since the measure of angle BAE is unknown and the measure of angle ABE is 38 degrees and the measure of angle AEB, I should say, AEB is given. So we will just look for the measure of angle BAE. So we will now substitute the measure of angle ABE, which is 38 degrees, and the measure of angle AEB, which is 90 degrees. And then we let the unknown be on the left side of the equation. So we will bring 38 and 90 degrees on the right side of the equation. So we will have 180 degrees minus 90 minus 38, or 180 degrees minus 128 degrees, and that is 52 degrees. The measure of the angle BAE is equal to 52 degrees. Okay, so another one, second part. Find the perimeter of kite LOVE given the measures x plus 5 for the distance from L to E and 2x plus 3 from the distance from L to O, and the distance from O to Y. O to B is Y, and the distance from E to B is 2y minus 10. So the first step of the solution is, since segment LO is congruent to segment LE, we can say that LO is equal to LE. So by substitution, we have 2x plus 3 is equal to x plus 5. Transposing x to the left and positive 3 on the right, we will have 2x minus x is equal to 5 minus 3. So 2x minus x is equal to x, and 5 minus 3 is equal to 2. Now we have LO is equal to 2x plus 3. So from the original given, we have 2x plus 3, and having now the value of x, which is 2, we will now substitute from this given. So 2 times 2 is 4 plus 3 is equal to 7 units. And then we will look also for the distance from O to V. So since line segment OV is congruent to line segment EV, we can also say that OV is equal to EV. So since if two parts are congruent, then their measures are also equal. So we have OV is equal to Y and EV is equal to 2Y minus 10. So we will substitute their values using the equation. So y is equal to 2y minus 10. And then since 2y is on the right, it is more appropriate to transpose y to the right so that the variable is positive. So transposing now y to the right side, so we have 2y minus y, and that is equal to y. And then transposing negative 10 on the left side, it becomes positive 10. Therefore, y is equal to 10 units. Since OV is equal to y, then we can say that OV is also equal to 10 units. Okay, so since we are finding for the perimeter, if LO is equal to 7, then LE is also equal to 7. And if OV is equal to 10, then EV is also equal to 10. So, the perimeter is equal to the sum of these four measures. So, perimeter is equal to 7 plus 7 plus 10 plus 10. It is equal to 34 units. The perimeter of Kite Love is 34 units. Okay, so that's all. Thank you for watching and learning from this video tutorial.